Okay, so let's talk about evaluating functions. Now let's suppose that the first function we're going to look at is this. We had f of x equals 3x minus 7. Now the first example, the first one we're going to do, part A, you've had before. You've had in a previous course. So my function is represented as 3x minus 7. And what kind of function is this? Is this linear, quadratic, linear? All right, it didn't matter if you knew whether it was linear or not with respect to what we're about to do, but you do need to know what kind of functions you're dealing with. So if I want to find f of, let's say, negative 5, what did you do in a previous course? Where we saw the variable x, you substituted negative 5. So I get 3 times negative 5 minus 7, right? And what's 3 times negative 5? And what's a negative 15 and negative 7? Use your calculator if you don't know this. Negative 22. So f of negative 5 will equal blank. What do you put in the blank? Negative 22. All right, now let's look at part B. Suppose in part B, you want to find f of 4x this time. So again, where we see the variable x, what do you substitute? 4x. All right, so when I substitute 4x, notice what I get. I get 3 times x. In place of x, I'm substituting 4x. So 3x. See, this was x previously, right? What does it become? 4x minus 7. Now, using the order of operations, what's 3 times 4x? 12x minus 7, and there's nothing I can do. There's your answer. So notice that f of 4x is going to equal what expression? 12x minus 7. So whenever you substitute a number, we ended up with a number. When we substitute a variable expression, we end up with an answer that's a variable expression. Okay? All right, letter C. Suppose, now this is where we're going to start talking about variable expressions leading to what we have to deal with, and that's the difference quotient. But before we can do the difference quotient, which is important for next semester, or business calculus or calculus, we need to be able to do something like this. So let's suppose I want to find f of x plus 2. All right, now notice the variable expression is a binomial. The variable expression I had earlier, this right here, was a monomial, right? One term. This has how many terms? 2. But I'm going to do the same way. So I'm going to say, well, that's going to be 3. Wherever we see the variable x, what do I substitute? X plus 2. That's what that says. So 3 times in parentheses, just like I did the 4x, x plus 2, and then minus 7. Now you want to simplify this, though. So how did you simplify this expression that I'm circling right here? Distributive property. So that becomes 3x plus 6 minus 7. Now in the previous problem, when I got to this point right here, there was nothing else I can do because there weren't any like terms. But notice, what can I do here? Combine like terms. So when I combine like terms, I get 3x minus 1. So f of x plus 2 is going to equal, and what do I put in the blank? 3x minus 1. All right, let's do one more with the linear one. So let's do letter D. Suppose I want to find f of 5x minus 1. F of 5x minus 1. So again, I go to my function f, and here's my function f. So remember, your function f was this. F of x equal 3x minus 7. So that was your function. So wherever we see the variable x, what do you substitute this time? 5x minus 1. So I go and I substitute 5x minus 1 into this linear function. When I do that, I'm going to get 3 times. In place of x, I'm going to substitute 5x minus 1. And then I'm going to subtract what number? 7, right? All right, now how do you deal with this expression that I'm circling? Distributive property. So I get 15x minus 3 minus 7. And so what do I do now? Combine like terms. I get 15x minus 10. So f of 5x minus 1 equals 15x minus 10. So you know what f of x is. What's f of x equal to? F of x. No. But what expression is it equal to? 3x minus 7. So if I want to evaluate it at 5x minus 1, then this becomes what expression? No. What expression does it become when I evaluate it at 5x minus 1? 15x minus 10. Okay, that's what it becomes. All right, let's do a quadratic. So that was linear. So when we do the difference quotient, we're going to do the difference quotient next class period. But when we do the difference quotient, we're going to look at it in terms of a linear function and also a quadratic function. All right, so let's do one that's quadratic. So let's look at number 2. So number 2, let's suppose I had this. G of x equal negative 2x squared plus 4x minus 1. G of x equal negative 2x squared plus 4x minus 1. Okay, so A, it says you want to find g of negative 4. So just like we did a while ago, how do you find g of negative 4? So wherever you see the variable x, you're going to plug in negative 4. Now, I'm substituting a number, right? So what should my answer be? A number. If I were substituting a variable expression, an expression that had variables in it, my answer would contain a variable expression. But here I'm just substituting a number. And so wherever you see the variable x, I'm going to substitute negative 4. So I get negative 2 times negative 4 squared plus 4 times negative 4 minus 1. All right, so wherever you see the variable x, I substitute negative 4. Now it's just a matter of you using the order of operations. So according to this, what order of operations would you do first? The exponent. So what's a negative 2 squared? I'm sorry, negative 4 squared? 16. So you agree that's 16 right here, right? But what's 16 times a negative 2? All right, and what does this become? Negative 16 and then minus 1. All right, and then we add and subtract from left to right. So what's a negative 32 and a negative 16? Negative 48. And what's a negative 48 and a negative 1?
Negative 49.
All right, so what is g of negative 4? Negative 49. Okay. So when x is negative 4, what's the y value? Negative 49. All right, B part. In B, you want to find g of x minus 4. So you want to find g of x minus 4. Now, I'm going to go ahead and rewrite my function g again. And it's this right here. So g of x, remember, was negative 2x squared plus 4x minus 1. So wherever you see the variable x, what do you substitute this time? X minus 4. So where you see the variable x, I'm substituting x minus 4. Okay? Now remember, in the previous problem we did, f of x was what kind of function? A linear function. So f of x was a linear function. So when I substituted, like let's say f of x plus 2, when I found f of x plus 2, it wasn't difficult. I used what property over here? Distributive property. Same thing here. When I evaluated 5x minus 1, what property did I have to use here? Distributive property. Okay? Now in number 2, what kind of function is this? Huh? It's quadratic. That's a quadratic function. X squared. Your largest exponent is 2. So x squared, that's quadratic. So when I substitute x minus 4, though, look what you're going to get. You're going to get negative 2 in parentheses x minus 4. But what am I doing to x minus 4 right here? Squaring it. You got to say that. Plus 4 times what? X minus 4 and then minus 1. So that's what this looks like. Now you got to simplify this, though. So do the exponent first. So you have x minus 4 times what? This means x minus 4 times what? X minus 4. So you got to go off to the side and figure out what x minus 4 times x minus 4 is. And how do you do that? FOIL. When you multiply two binomials, you use the FOIL method. So what's x times x? What's the outer? What's the inner? And what's the last? Positive 16. So what does this become? X squared minus 8x plus 16. So that's what this is right here, though. So all I found at this point was what part of this expression that I'm circling. The binomial squared, x minus 4 squared. So that right here is this. But what must I do with this trinomial right here? Multiply by what? Negative 2. So it becomes negative 2 times x squared minus 8x plus 16. Now right here, what's the best way to simplify this part at this point? Distributive property. So this becomes plus 4x minus 16, right? And then minus 1. Now, can I combine like terms right now? No, because what else can I do? I can use the distributive property in that first one as well. So what does that become? Negative 2x squared plus 16x minus 32, and then plus 4x minus 16 minus 1. And now what's your answer? Combine like terms, so what will be the answer? Negative 2x squared. What about the x's? Plus 20x. And your constants, how many constants are there? There are 3. A negative 32, a negative 16, and a negative 1. Negative 49? All right, so there's your answer. All right, now notice this one's a little bit more work. So when you deal with a quadratic, it's a little bit more work. So you're going to be squaring, in this case, a binomial, so you have to use the FOIL method. All right, so notice the difference between part B of number 2, when you have a quadratic, and part C of number 1, when you have a linear function. See, here I didn't have to use the FOIL method at all because x plus 2 is being raised to what power? X plus 2 is being raised to the first power. So I just had to do the distributive property. All right, now let's suppose I had this. I'm just going to kind of put this as number, let's see, that was 1, 2, 3, 4, 5. Let's do number 6 here. Right, it's number 6. So let's suppose h of x is 3x squared minus 7x minus 3. So 3x squared minus 7x minus 3. And let's suppose I want to find a. Suppose I want to find h of 5x. So how do I find h of 5x? Where we see the variable x, what do you substitute? 5x. So I get 3 times in parentheses, put your parentheses there, 5x, but what am I doing to this 5x? Squaring it. Minus 7 times in parentheses, what is, that becomes 5x, and then minus 3. Now you got to simplify this. So according to your order of operations, what will I do first? In this case, the exponent. Now notice, this is a monomial, so really what you're saying is 5x times what? 5x. What is that? 25x squared. That's what that is. But that 25x squared has to also be multiplied by what? 3. So that's 3 times 25x squared, right? Now over here, what is this right here that I'm doing? Oh, now someone said distributive property. Am I really distributing here? No, because this is not a binomial or a trinomial or anything with more than two terms. This is just one term. So you're basically saying negative 7 times 5x, which is a negative 35x. That's what that is. And then minus 3. And now this part here is what though? 75x squared minus 35x minus 3. Can I combine like terms? Nope. So there's your answer. Now let's suppose I had part B. Let's suppose part B was this. Suppose I want to find h of 2x plus 3, let's say. H of 2x plus 3. This time I'm substituting a binomial in there. Now I won't give you anything with more than a binomial. I won't give you a trinomial because if I give you a trinomial, you're going to be squaring that. That's not that easy to multiply a trinomial by itself. But remember, your function was this. This was your function. And so wherever you see the variable x, what do I substitute? 2x plus 3. So this becomes 3 times 2x plus 3. What do I do to that 2x plus 3? Squared. Minus 7 times what? 2x plus 3, and then minus 3. All right, now according to your order of operations, what do I do first? The exponent. So that 2x plus 3 times itself. So go off to the side and figure out what 2x plus 3 times itself is. How are you going to multiply this out? The FOIL method. So it's 2x times 2x. What's the outer? What's the inner? And what's the last? 9. Combine like terms, you get 4x squared plus 12x plus 9. Now what is it that I found? What is it that I found? I found that binomial squared. But there's a lot more stuff involved here, right? Now this trinomial that I just found, this trinomial expression right here, that has to be multiplied by what number though? 3. So make sure you put that in parentheses. So it's 3 times this trinomial. See, all I found was this. So this is this trinomial, right? But it's also being multiplied by 3. Now I'm going to go ahead and use the distributive property here. And that becomes what? Minus 21 minus 3, right? Now let's use the distributive property here. So that becomes right here, when I get rid of the parentheses, 12x squared plus 36x plus 27 minus 21 minus 3. And then finally, what's the answer? 12x squared. Let's see, 36x and a negative 14x is 22, is that right? All right, now what's a positive 27 and a negative 21? That's 6. Yes or no? Yes. Okay, and what's 6 minus 3? 3. So this is h of 2x plus 3. So h of 2x plus 3 is going to equal this. Now, that's important to be able to do because when we do the difference quotient next week, you're going to be doing that same thing I did here, where you had to square a binomial. So you're going to see what that's going to look like. Yeah, difference quotient next week. So next week will be the difference quotient. So in order to do the difference quotient, you need to be able to do something like we just did in both cases, number 1 and number 2. So in test 3, when we do the difference quotient, it's either going to be a linear function or a quadratic. And in order to be able to do this, you have to know what we just did. Okay? All right, now let's go back and on this handout we did that I gave you, we said this was number 1, this was number 2. let's make this number 3 right here. So this is number 3. So number 3, you have this. You have g of x is this absolute value function. All right. Now remember, that's an absolute value function. That's not a linear function. It's not a quadratic function. It's an absolute value function. Their graphs are different. And if I want to find a, and a says find g of 4. Now that's always the easy kind, is to evaluate it at a number. So wherever we see the variable x, what do you substitute? 4. So, and only see the variable x only once here. So that becomes, now you still have to put the absolute value bars right now. That's the absolute value of 2 times x. What's x? 4 plus 1. And whatever that absolute value is, I've got to subtract what? 3. All right, so that's where I'm at. So in my math lab and on the worksheet, you are going to have an absolute value expression. So make sure you work it out like this so you don't mess up. Now you got to work within the absolute value bars for right now. Forget about the minus 3. Forget about subtracting 3 for right now. In the absolute value bars, you have a multiplication and you have an addition. What do you do first? Multiplication. What's 2 times 4? So it becomes absolute value of 8 plus 1. Whatever that is, I'm going to subtract 3. What's 8 plus 1? So it becomes absolute value of 9 minus 3. But what is the absolute value of 9? Now I can get rid of the absolute value bars because I know the absolute value of 9 is what? And what's 9 minus 3? 6. So g of 4 is going to equal what? 6. Okay? So if you were to graph this function, and what does the graph look like for absolute value? Do you remember?
2 lines.
That's that V. Yeah? The V, right? The V shape. So when you graph this, what point would be on the graph when x is 4 and y is what? 6. So that point, 4, 6, would be on this graph. All right, B part, you want to find g of negative 3. Do the same thing. Wherever you see the variable x, what are you going to substitute? Negative 3. But remember, we're still dealing with absolute value here, so you need the bars. So that's 2 times negative 3, just like this, plus 1. And whatever that absolute value is, you're going to subtract what? 3. All right, now work within the absolute value bars for right now. I have a multiplication and an addition problem. What do I do first? Multiplication. So that becomes the absolute value of negative 6 plus 1, right? Whatever that is, I'm going to subtract 3. What is negative 6 plus 1? So that becomes absolute value of negative 5 minus 3. But now I can remove the absolute value bars. What's the absolute value of negative 5? And what's 5 minus 3? 2. So what is g of negative 3? 2. So that means that when x is negative 3, my y value is what? 2. Okay? Now remember, like we said, whenever we evaluate an expression at a number, I end up with a what? Number. So notice that my y value was a number. My y value here is a number. Now let's do one where, letter C, where it's not a number, a numerical expression, but it's a variable expression. So this is C. So C, suppose you want to find g of x minus 5. G of x minus 5. So let's go ahead and write the function again. So what was g of x? The absolute value of 2x plus 1 minus 3. All right, so where we see the variable x, and it's right here, what do I substitute? X minus 5. Now, and you're going to work it out just like you did the previous problems. So you're going to say, well, that's going to be the absolute value of 2 times, in parentheses, what do I put inside the parentheses? X minus 5. Plus 1, absolute value, right? Whatever that is, you're going to subtract 3. Now, look inside the absolute value bars. How do you deal with this expression I'm circling? Distributive property. Very good. So it becomes absolute value of 2x minus 10 plus 1 minus 3. Now, what do you think you're going to do with what you see inside the absolute value bars? Combine like terms, so it becomes absolute value of 2x minus 9, right? Minus 3. All right, now this is where we're at. Notice when we did A and B, we'll go back to A and B, when I got to this point right here, I was taking the absolute value of a number. And we know how to take the absolute value of a number. Remember, it's the distance that number is from 0. So this was a numerical expression. That was just 9. So I removed the absolute value bars because I knew what that was. What's the absolute value of 9? 9. I know what the absolute value of negative 5 is. What's the absolute value of negative 5? 5. So I removed the absolute value bars. But now I'm dealing with an expression. You can't just remove the absolute value bars like that. Because this variable could be 0, this variable could be a positive number, this variable could be a negative number. I don't know what it is. So basically, this is your answer. That's all you can do. That's all you can do. Don't remove the absolute value bar because you don't know anything else. Okay? So let's go back to 1 and 2 and kind of see some similarities. When I did number 1, go back to number 1. When I did number 1 for part C, what kind of expression did I have here? Linear. Linear, right? When I evaluated at a variable expression, a variable expression, a variable expression, I ended up with what kind of function in all cases? Right here. Linear. So you start with the linear, you end up with a what? Linear. Okay, let's look at number 2. When I did number 2, this was what kind of function? Quadratic. When I evaluated at a variable expression, I ended up with what kind of function? Quadratic. Same thing here, quadratic. So if I start with an absolute value function and evaluate an expression, I better end up with what kind of function? Absolute value function. Okay, so kind of make those similarities because what some students want to do is remove the absolute value bars. The only time you can do that is if this is what kind of expression, variable or numerical? Numerical. Numerical means a number. This is variable, so you can't do anything else. Leave it alone. Okay? All right, let's look at number 4 now. So this number 4 is going to be the square root. So go ahead and change this to number 4. So number 4, you have this. You have h of x is the square root of 3x minus 2 plus 5. So h of x is the square root of 3x minus 2 plus 5. And then in letter A, you want to find h of 7. Now that's the easy kind when you're evaluating at a number. So basically, wherever you see the variable 7, the variable x, I said the variable 7. The variable x, you're going to substitute what? 7. So this becomes the square root of 3 times 7 minus 2 plus 5. Now work within the radicand. What's 3 times 7? And what's 21 minus 2? 19. So I get the square root of 19 plus 5. Can I simplify this? Can I combine like terms? Are these like terms to begin with? No. Those are not like terms. This is an irrational number. This is a rational number. This is a square root. This does not. So there's your answer. So h of 7 is just the square root of 19 plus 5. So for some of these situations, you got to kind of remember how to write the answer. That's all you can do. Okay? Part B, Let's suppose we want to find h of 2. H of 2. So, again, the same thing. Where we see the variable x, what do I substitute? 2. So I get square root of 3 times 2 minus 2 plus 5. What's 3 times 2? What's 6 minus 2? All right, now here's what I have. I have the square root of 4 plus 5. So that's where I'm at, right? So what I had in part A looks the same as in part B. But I can go further with part B. Why is that? Because you know how to deal with the square root of 4. What's the square root of 4? 2. So 2 plus 5 is what? Yeah, see, now you can combine like terms, right? Because both of those are rational numbers. 2 plus 5, you know what that is? That's what? 7. So h of 2 this time is just what? 7. So notice the difference between part A and part B, how your answers were written. Okay? All right, part C. Now we're going to substitute, we're going to evaluate it at a variable expression. So this time it's h of 3 minus 2x. So let me go ahead and rewrite the function. So h of x, remember, was this radical? 3x minus 2 plus 5. So where we see the variable x, what do I substitute? 3 minus 2x. That's what I substitute. So I'm going to get the square root of 3 times, in parentheses, what do I substitute? 3 minus 2x. And whatever that is, I'm going to have to add, I'm going to have to subtract 2, right? So see right here? Whatever that square root is, I'm going to have to add what, though? 5. All right, so work within the radicand. How do I get rid of these parentheses that I put in there? Distribute. So I get the square root of, and that becomes 9 minus 6x minus 2 plus 5. Combine like terms, I get the square root of what? 7 minus 6x plus 5. And just like with the absolute value, there's nothing else you can do. Remember part C of the absolute value right here? I was done. I can't do anything else. So I'm done. So this right here, you would say h of 3 minus 2x equals blank. What goes in that blank? The square root of 7 minus 6x plus 5. All right, so just a matter of you remembering how to write the answer. So on the worksheet, you are going to have a square root. You are going to have absolute value. Just use these examples as a guide. And then finally, let's look at the next problem, number 5. So number 5 this time is this. It looks like this. You have k of x is the absolute value of 3x minus 2 in parentheses in the numerator. And the denominator is just x plus 2. So that's k of x. So in my math lab, you're going to see one like this. All right. Now, part A, that's the easy kind, part A, because you're evaluating at a number. That's the easy kind. So we see the variable x, what do you substitute? 3. All right, now watch what I'm doing. So my numerator has this absolute value, right? Okay, so make sure you leave the absolute value bars for right now. So I'm going to take the absolute value of 3 times x. What does x become? 3. Whatever that is, I'm going to subtract 2, correct? All right. So I'm going to leave the denominator alone for right now. Let's still work with the numerator. What's 3 times 3? So that becomes absolute value of 9 minus 2, correct? Still working with the numerator only. What's 9 minus 2? So that's absolute value of 7, which we know is exactly what? 7. So that's my numerator. Okay, see how it looks? All right, let's talk about the denominator. My denominator becomes 3 plus 2, which is just what? 5. So let's talk about what we have now. So in place of the variable x, what do I substitute? 3. So this becomes the absolute value. See right here, this first one right here. 3 times 3 minus 2. And the denominator becomes what? 3 plus 2. The numerator is a little bit more complicated to deal with than the denominator. The denominator, you know what it is right away. What is it? 5. It's just 5. But the numerator has an absolute value bar. So let's see if we can go further with it. Let's see if we can get rid of the absolute value bar. In letter C, I could not. In letter, if I can find it, in part B, I could have, because I'm taking the absolute value of 9, right? We all know the absolute value of 9 is 9. So my answer did not have an absolute value in it. Absolute value bar. Same thing for part B. But when I did part C, it did. So now we're looking at this. What's 9 minus 2? 7. And I know the absolute value of 7 is what? 7. So all these denominators though are what? So therefore you're going to say this. In the blank, you're going to say k of 3 equals blank. What do I put though? 7 over 5. That's what you put. Okay? All right, so make a comparison between all the stuff we've done. Part B, you want to find k of negative 2. K of negative 2. So same thing. Where we see the variable x, you're going to substitute what? Negative 2. So I'm going to get the absolute value of 3 times negative 2. Oops. The absolute value of 3 times negative 2, subtract 2, right? Over negative 2 plus 2. Right away, what is the denominator? 0. It doesn't matter what the numerator is. We'll finish working it out. But whenever you divide by 0, what do you remember about that? No, not 0. That's undefined. Remember, you can never divide by 0. In fact, remember on test 1 where you had to find the restrictions? Because you can't divide by what number? 0. So right away you would say this, k of negative 2, you would say undefined. But let's finish the numerator. What's 3 times negative 2? So it becomes negative 6 minus 2, right? What's a negative 6 and a negative 2? Negative 8. So it becomes absolute value of negative 8 divided by 0. But what is the absolute value of negative 8? And what's 8 divided by 0? Undefined. All right. Let's do B star. Put a B star there. Let's say you want to find k of negative 4. K of negative 4. Let's do that one. K of negative 4. So wherever you see the variable x, what do I substitute? Negative 4. So I get the absolute value of 3 times negative 4, subtract 2. Divided by, remember, wherever you see the variable x, I substitute negative 4. So it'll be negative 4 plus what? 2. The denominator is easy. What's the denominator? Negative 2. All right, let's work with the numerator. According to the numerator, when I look inside the absolute value bars, I have a multiplication and a subtraction. What do I do first? Multiplication. What's 3 times a negative 4? So that becomes absolute value of negative 12 minus 2. But what is negative 12 and a negative 2? Negative 14. Absolute value of negative 14, right? Don't get rid of the absolute value bar just yet. But what is the absolute value of negative 14? And what is 14 divided by negative 2? Negative 7. Very good. So what is k of negative 4? Negative 7. All right. It's just practice. You've got to just practice on these. And then finally, letter C. You want to find k of x plus 5. I'm going to go ahead and rewrite my function. K of x, remember, was this. The absolute value of 3x minus 2 divided by x plus 2. All right. So where we see the variable x, and I see it here and here, I'm circling them. That's where I see them. What does that circle become? X plus 5. So it becomes the absolute value of 3 times in parentheses x plus 5, subtract 2. See what I did? So that's, remember, my original function was 3x minus 2 inside the absolute value bars. But this time, x becomes what? X plus 5. All over, this is x right here, right? So that becomes what? And then I got to add what? 2. All right. Now the denominator is easy. What's the denominator? X plus 7. All right, let's talk about the numerator. Okay, work within the absolute value bars. Don't get rid of the absolute value bars just yet. How do I work within the absolute value bars? Distribute. Very good. So that becomes absolute value of 3x what? Plus 15 minus 2. So that becomes absolute value of what expression? 3x what? Plus 13, so you combine like terms. Over x plus 7, right? Can I get rid of the absolute value bars? No. So that's your answer. So k of x plus 5 is just what? 3x plus 13 divided by x plus 7. And the reason you can't get rid of the absolute value bars is because you don't know what x is. X could be 0, x could be negative, x could be positive. Okay, you really don't know what it is. So you leave it alone. Okay? All right. So that was that part of the worksheet, or that part of the lesson. All right, so remember the numbers 1 and 2, though. 1 and 2, in order to be able to do something with the difference quotient that we're going to do next week, you have to be able to do 1 and 2, especially squaring a binomial. So make sure you go back and review 1 and 2 for next week. All right. Now, let me give you the worksheet